So this is the 51st session on relative velocity. This is in continuation of the 50th video. So in this video also we'll discuss the relative velocity problems for mutually translating frames for case 3. Okay. As far as case 3 is concerned, case 3 starts from 49th video. Okay, and regarding details of case 1, case 2, case 3, we get you get the details in 42nd video. All right. So I'll take up a question on relative velocity in session 51 for case 3. Okay. So I'll write down the question. Okay. C1 and C2 are two cities separated by distance L. C1 and C2 are two cities separated by a distance L such that C2 is 60 degree north of east with respect to C1. C2 is 60 degree north of east with respect to C1. Air flows at a constant speed of with respect to ground along eastward direction at a constant speed of u with respect to ground along eastward direction. An aeroplane whose speed with respect to air is 3u flies from C1 to C2 and then back to C1. Find the time taken by the plane for the complete journey. Find the time taken by the plane for the complete journey in terms of L and U. Okay. All right, fine. So this is the question. Okay. I'll rub it. Okay. So this is the problem. Okay. So first of all, what we'll do, we'll decide the object and frames under consideration. Then object under consideration is plane which is denoted by P, say, aeroplane denoted by what? P. Instead of M frame, we have the air frame denoted by A. Instead of F frame, we have the ground frame denoted by G. Alright. Now plane flies from C1 to C2 and then back to C1. So first what we do, we draw the diagram in the top view. This is C1, this is C2. L is the distance between these two cities. C2 is 60 degree north of east with respect to C1. So this angle is 60 degree. Okay. Now plane flies from C1 to C2 and then back to C1. Let T be the total time taken by the plane for the complete journey. T be the total time for the complete journey. Okay. So T will be what? T1 plus T2, that is equal to T. T1 plus T2, that is T. Here T1 is what? Time taken by the plane to fly from C1 to C2. And T2 is the time taken by the plane to fly from C2 to C1. Now to know T, we have to know T1 and T2. So first we determine T1. Plane flies from C1 to C2 at a constant speed Vsg1 with respect to ground, say. And it covers a distance L with respect to ground. So time taken T1 is equal to distance by speed L by Vsg1. This is T1, alright. So T1 becomes L by how much? Vsg1. Now to determine T1 we must know Vsg1. L is already known. We have to know Vsg1. Now question is how to find Vsg1. For that what do we do? This is not Vsg1, sorry. This is Vpg1, sorry. Vpg1. T1 is equal to L by Vpg1. Now to find T1 we must know Vpg1. To determine Vpg1, we write down the formula for translating frame velocity relation. Vpf, instead of Vpf, we write Vpg1 is equal to Vpa1 plus Vag. Alright. Now see, Vag, we have complete information U along eastward direction. So magnitude and direction both known. For Vpa1, what about Vpa1? We know the magnitude, how much it is? 3u. Okay. Velocity of plane with respect to air 3u, but direction not known. Vpg1 we know the direction C1 to C2, but magnitude not known. So therefore it's this we have complete information. This we have only magnitude only, not direction not known. And for Vpg1 we know the direction but not the magnitude. Therefore again the problem of case 3. Okay. Case 3 problem starts from 49th video. So this is in 51st video. Okay. And what is detail case 3, that you can get in the 42nd video. Okay. So now what do? We draw the vector diagram. So first what do? We draw the arrow for these two vectors with the tails coinciding. So this is Vag, this is U. This is Vpg1 at an angle of 60 degree north of east. Now we have to draw the arrow for Vpa1. Tail of Vpa1 coincides with the tail of these two vectors, and it is on the side of Vpg1 not containing this, that is on this side. So this is Vpa1, this is 3u. Let us call the triangle as theta, we don't know. Now with these two as adjacent side, we complete the parallelogram such that this is the diagonal of the parallelogram. See, alright. So we have drawn the parallelogram. It is not a right angle triangle. Okay. So this side a bit, okay. So now Vpg1 from the theory of vectors, Vpg1 is equal to 3u cos theta plus u cos 60. 3u cos theta plus u cos 60, and that is u by 2. Now to know Vpg1 we must know theta. Now how to find the value of theta? Vpg1 is the resultant of these two, 3u and u. Resultant of these two is along this direction. So resultant of these two in a direction normal to Vpg1 is 0. That is component of these two vectors in this direction cancel out. So 3u sin theta is equal to u sin 60. 3u sin theta is equal to u sin 60 degree. U and u cancels out. Sin theta, sin 60 degree is root 3 by 2. Sin theta becomes 1 by 2 root 3. This becomes sin theta. Alright. So sin theta is how much? 1 by 2 root 3 is the value of sin theta. So from this we can get the value of cos theta. From trigonometry, cos theta becomes root under 1 minus sin square theta. 1 minus sin square theta and 1 by 12. 2 root 3 ka square of this is 12. This is 11 root 11 by root 12, 2 root 3. This is the value of cos theta. Alright. Now cos theta I substitute in this, I get VPG1. Alright. This I rub it, okay. So I substitute cos theta in this equation. So VPG1 becomes 3u, cos theta becomes root 11 by 2 root 3 plus u by 2. So this becomes root 3 cancels, the u root 33 by 2 plus u by 2. This is VPG1. Alright. Now substitute the value of VPG1 in the expression for T1. So T1 becomes L by VPG1, u plus u root 33 by what? 2. Okay. So this becomes 2L by u times root 33 plus 1. This becomes T1. Alright. So this is the value of T1. Alright. T1 is 2L by u times root 33 plus 1. This is the value of T1. Alright. Now we have to determine the value of T2. Okay. So for T2 we write down the expression for T2 first. T2 is the time taken by the plane to fly from C2 to C1. When the plane flies from C2 to C1, it covers a distance L with respect to ground at a constant speed, say VPG2. So time taken for the reverse journey is distance by speed, VPG2. Okay, fine. So I have this one. Now, to find T2, we must know VPG2. To know VPG2, we must write down the vector equation. So, VPG2 is equal to VPA2 plus VAG. Again, we know the complete information about VAG. U eastward, magnitude, direction both known. For this, we know the magnitude 3U, but direction not known. For this, we know the direction C2 to C1, but magnitude not known. Therefore, it's again a problem of case 3. Okay. So now to determine VPG2, we draw the vector diagram. Now when we draw the vector diagram, we first draw the arrows of these two vectors with the tails coinciding. So VAG is this way, U. We draw the arrow for VPG2 with its tail coinciding with that of VAG. So it is something like this. This is VPG2, return journey VPG2. This angle will be 120 degree by geometry because this was 60 degree. Interior angle triangle 60 degree, 180 120 degree. Now we have to draw the arrow for VPA2. The tail of VPA2 will coincide with the tail of these two vectors, and it will be on the side of VAG, on the side of VPG2 not containing VAG. There is something on this side. This one. Okay. So this becomes how much? This becomes VPA2, that is 3U. Now with these two adjacent sides, we complete the parallelogram so that this is the diagonal of the parallelogram. This one. Okay, fine. Alright. This one. Alright, clear? Now suppose we denote this angle by alpha. Alright. This side, rub it. this also I'll rub, okay. This result I'll write it here so that I don't forget it, okay. I'll just write the result here, T1, it will use subsequently. If I rub it, I'll forget the formula result, so I write it here. (12 by u root 33 plus 1). Alright, fine. So now we have to determine T2. Sorry, VPG2. If VPG2 becomes from this diagram, VPG2 becomes 3u cos alpha plus u cos 120 degree. Cos 120 degree is minus half. Now to know VPG2 we must determine alpha. So how to determine alpha, that is the question. So VPG2 is the resultant of these two. Now resultant of these two is in this direction. And resultant of these two in direction normal to VPG2 is 0. So component of u and 3u in direction normal to VPG2 becomes 0. So u sin 120 is equal to 3u sin alpha is equal to 3u sin alpha. So u goes away. Sin 120 degree becomes root 3 by 2. This becomes sin alpha. So from this we see sin alpha becomes 1 by 2 root 3. This becomes sin alpha. So from this I get cos alpha. Cos alpha from trigonometry is root under 1 minus sin square alpha. And when you simplify it, 1 minus 1 by square of this quantity is 1 by 12. Root 11 by 2 root 3 is the value of cos alpha. I substitute cos alpha in this. So VPG2 becomes 3u root 11 by 2 root 3 minus u by 2. This becomes u by 2 root 33 minus 1. This is the time for VPG2. Okay. So time for reverse journey is L by VPG2. L by u root 33 minus 1 into 2. This becomes T2. T2 is 12 by u root 33 minus 1. This is the value of T2 for the reverse journey. Okay. Now I rub this one. So now total time for journey is T1 plus T2. T1 is this one, T2 is this one. So T total time for journey is T1 plus T2. So T1 becomes how much? This T1 I have written it here. 12 by u root 33 plus 1. 12 by u root 33 minus 1. So this becomes 12 by u common plus 1 by root 33 minus 1. 12 by u, when you simplify it, if you add these two in numerator, it becomes 2 root 33, and this a square minus b square, root 33 plus 1 into root 33 minus 1. Okay, this becomes 12 by u 2 root 33 minus 1, 32. This becomes 32. So 2 to 4 cancels out. L root 33 by 32 u. 2 to 4, sorry, this will not be here, this will be L root 33 by 4, 8u is the required answer. Alright. So total time for complete journey is L root 33 by 8u. This is the required time for the plane for the complete journey. Alright. Time taken by the plane for the complete journey. This is equal to L root 33 by 8u. This is therefore the required answer. Alright, fine. Now this error bit here. This is a rabbit, okay? Now I take up one more problem on this case 3 in this session. Okay. This is the problem. A straight river flows towards east at a u with respect to ground. P1 and P2 are two vertical poles fixed in the river bed. Two vertical poles fixed in the river bed and are separated by a distance L such that P2 is due north of P1. S is a swimmer whose swimming speed with respect to river is u root 2. The swimmer swims from P1 to P2. Swimmer swims from P1 to P2. Find the time taken by the swimmer for the complete journey. In terms of L and U. This is a little bit, okay? In case there is any careless mistake, you please write down, refer to it in the comment box, okay? So I'll try to rectify it, okay? So now first what we do again, we identify the object under consideration and frames under consideration. So object under consideration is swimmer, which is denoted by S say. Instead of M frame we have river, denoted by R say. Instead of F frame we have the ground frame, denoted by G say. Alright. Now what do? We draw the diagram of the situation in top view. This is the river flowing rightward at a constant speed u with respect to ground, top view. This is the north bank, this is the south bank. These are the two vertical poles fixed in the river bed, P1 and P2. P2 is due north of P1 and distance L from P1, P2. Okay, then what do? We write down the vector equation. Now, time taken, let T be the time taken by the swimmer to swim from P1 to P2. The time taken by the swimmer to swim from P1 to P2, how to find? Swimmer swims from P1 to P2 with respect to ground. It covers a distance L at a constant speed, say Vsg. The time taken is equal to distance by speed, L by Vsg. This is T. The T is equal to L upon Vsg. This is the value of T. The time taken by swimmer to swim from P1 to P2 is L by Vsg. Now to know T, we must know Vsg. L is already known. We only have to determine Vsg. The question is how to find Vsg. For that, what we do, we write down the formula for translating frames. Vsg is equal to Vsr plus Vrg. Now Vrg, we have complete information, u, magnitude, direction eastward. Vsr, we know the magnitude u root 2, but direction not known. Vsg, we know the magnitude, direction P1 to P2, but direction not known. Now therefore it's problem of case 3. Alright. Now to know the magnitude of Vsg, we draw the vector diagram. So what do? We first draw the arrow for Vrg and Vsg with the tails coincident. So Vrg is in this direction, u. Vsg is in this direction. This is Vsg with the tails of these two vectors coinciding. Now we have to draw the arrow for Vsr. Tail of Vsr will coincide with the tail of these two. And Vsr will lie on the side of Vsg not containing Vrg. That is in this side. Something like this. So this is Vsr, that is u root 2. Now with these two adjacent sides we complete the parallelogram. And with this as the diagonal, Vsg as the diagonal. Now see, it's a right angle triangle, you can see. It's a right angle triangle, this was a right angle triangle. So that we directly deal with it. Now this is u, so this also will be how much? U. Alright. So this is also u. So from this you can see that this square plus this square equal to u root this square, Pythagoras theorem. Vsg square plus u square equal to u root 2 whole square. This becomes how much? 2u square. Vsg becomes how much? U. Vsg is equal to how much? Tell me. U. Alright. Vsg is just equal to u. Alright. Vsg square plus u square 2u square. Vsg is equal to u. We substitute this in this. So T becomes L by u. L by u, it is therefore the required answer. Alright. T is equal to L by u. Alright. So time T is equal to what? L by u, that is the required time for the taken by the swimmer for the complete journey. Alright. So this was the 51st session on relative velocity. Okay. Now in next session I'll take up some more problems. Then I'll take a problem from next session onwards. I'll take up problems on case 4. Alright. That will be the last phase of this chapter. This chapter will be finished. Alright. So you carefully go through it. Alright. And if you have any problem, you write down in the comment box. Okay. I close it here. Alright.